at domain and range. I know in Algebra 1, you probably looked at interval notation, but used inequality notation the majority of the time. It's going to be like the reverse in Algebra 2. We are going to focus and almost always use interval notation, but we still need to know inequality notation for some. Set notation is on here as an alternate notation that you may find in some college or older math books, but we're not going to use it. So I'm actually, it has a spot for me to show you set notation. I'm not even going to bother because I don't want to confuse you with a third notation. We're just going to look at inequality and interval and talk about the formatting of those, and then just do a quick few examples. And we're only going to do the examples in interval because interval is what we will almost always be using. Okay, I know we touched on domain and range last week with the linear parent function when we did that graphic organizer with the linear parent function. Okay, so y'all told me then that domain is our x's and range is our y's. And I showed you then that inequality notation, the formatting for it is you do your least value is less than, and then your x or your y, depending if it's domain or range, is less than your greatest value. Now, whether or not that inequality is just less than, or if it's less than or equal, maybe, is going to depend on if that least value or greatest value is included in the domain or range. Okay, so there's a little box down here, just where it's notating that if we will use, oh, that is supposed to be a highlighter. Let me erase that. We will use parentheses in interval notation or less than, greater than, without the equals if it's an open circle or if it's infinity, because we can't equal infinity. Okay, those are both the notations for the value not being included. So when we say included or not included, that's what's telling us whether or not we should be using the or equal sign or not. Okay, so if the value is not included, okay, we would use just the less than. We would not have the or equal. Okay, we would use it with the or equal sign if it's a closed circle at the end or if the value is included. And in interval notations, that's when we would use the bracket. Okay, so included versus not included tells us whether we're going to use the or equal sign on inequality. For interval notation, we do least and greatest, but we don't write the x or y in between them. We just do least, comma, greatest. And then there's no inequality symbol. So to show that the value is included or not included, we use a parenthesis or a bracket on that value. And you can have them match. They could both be parentheses or they could both be brackets, or you could have one of each. Okay, they could be mismatched. Okay, so in this specific example, I've got an open circle on the left where x is -3, and I've got a closed circle on the right where x is 1. So I like to get y'all in the habit of marking on your axis what that least and greatest value is. So for the x's, I'm going to put a mark here at -3. And if you can't see that says -3, I'll write it bigger. So it goes from -3, that's my least value. And the furthest right the graph goes is here to 1. That's my greatest value. So in interval notation, I would just say -3, comma 1. Now I need to decide if I should be using a bracket or a parenthesis on each side. And so I'm going to look down here. Okay, if it's included, it's a bracket. If it's not included, it's a parenthesis. So at -3, it was an open circle. Okay, that means not included. So on the -3, I'm going to use a parenthesis. But over here at the 1, that was a solid point. Okay, that is included. So I'm going to use a bracket. Okay, I'll highlight on those. So I used a bracket here and a parenthesis here to show that the -3 is not included, the 1 is included. Now, in inequality notation, least and then less than, and this is domain, so x, and then less than, and then our greatest is 1. So now I just have to decide, am I supposed to put an or equal on one of these less than symbols? And we said the 1 is included, x can equal 1, so I do need to put the or equal on that one there. Why will you not draw? Are you kidding me? Hang on, I don't know what's going on. It's done this before. I'm gonna close this and reopen it and see if it makes a difference. And will let me write on it again. There it goes. Okay, so we need that or equal on that side. Because again, this one was not included. The 1 is included. Y'all good with the difference on when to use which one? Okay, now let's talk range. Range is our y values. So I'm going to mark on my y-axis, the lowest this graph goes is down here at -4. What's the highest this graph goes? Along the y-axis. No, it does. 1, yeah, 1 is up here. The graph is not up here at 1. It's right here at 0. So 0 is the highest the graph goes. So -4 to 0, that's my least to greatest for range. But I need to decide if I'm going to use parentheses or brackets. And I do need to make sure I'm going least to greatest. Don't put 0, -4. It is -4 to 0. Okay, and down here at -4, when I look left and right from that, my graph exists in 2 places down here. Do y'all see that? So it's definitely included. It exists here and over here. So the -4 has a bracket because it's included. And then up here at 0, if I look to the left, there's an open circle, which is not included. However, right where I am, do y'all see how the curve comes up and passes through here? So the graph does exist where y is 0. So even though over here on the left is an open circle, it exists here at 0. So the 0 also gets a bracket. So in inequality notation, I would have -4 is less than or equal, because the -4 is included. And then I'd have y, because this is range, is less than or equal, because the 0 is included. Okay, and then the 0. Okay, this tells us x is everything between -3 and 1, including the 1. Y is everything between -4 and 0, including the -4 and the 0. You ready to try a couple examples? We're going to focus again on interval notation. This is the one that we are going to use most often. Okay, so we've got to understand when to use parentheses, when to use brackets. Okay, so let's take a look at example 1 here. We've got the left, how far, I'm going to mark on my axis, how far left does this graph go? What's the leftmost x value? That's -3, good. And what's the rightmost x value here? 2. So my x's are going from -3 to 2. Are there any like gaps or breaks or anything in this curve in between there, or it's all connected? Yeah, so my domain is everything here between -3 and 2. Okay, so my domain will be -3, 2. Now I have to decide on parentheses or brackets. So at -3 does the graph exist at -3? Yeah. No, it's an open circle. So the open circle means the -3 is not included. So that one's a parenthesis. Yes, because it's a solid point at 2. So that is included. So that one's a bracket. Okay, what about the range? How low? What is the lowest y value of this graph? It's down, I would say down here, right? That's the lowest. The curve never gets below this. And that is at, yeah, -2. Okay, the highest this goes is up here. That's at 4. So least to greatest. Now, are there any gaps or breaks or anything where it doesn't exist in between those? There's not. So it's everything here is in my range. So -2 to 4. And now I've got to decide parentheses or brackets. So down here at the low point, it is not included because it's an open circle. But here at the high point, it's solid, it is included, so that should be a bracket. I'm going to do the same thing on 2. I'm going to mark the leftmost that my graph goes and the rightmost. And that's -3 and +2 again. So -3 to 2 again. But this time, notice at both of those, we've got an open circle. So how's it going to be different from the domain in number 1? Both are going to be parentheses. Very good, Kari. All right, now let's mark our y's. The lowest this goes is -3. And the highest this goes is 4. I don't want my notifications. Go away. Bless you. All right, so we've got -3 to 4. Okay, so -3 to 4, and it's everywhere in between there, right? Some people in my morning classes will say, well, what about right here where y is 1? Because there's an open circle there. But if we look across over here, the line passes, the curve passes through, doesn't it, on this side? So it exists there. Okay, so even though there's an open circle at when y is 1 over here, it exists when y is 1 over here. So that's not a gap in our range. Our range is still everything between those. Okay, but here at the bottom, we do not include the -3, so that's a parenthesis. And at the top, the curve, it passes through there, doesn't it? So it is included. It exists up there where y is 4. So that is going to be a bracket. A little bit prettier there. Y'all okay with those? What is different about example 3? How does this look any different than those? Yeah, there's a discontinuity. It's disconnected. This is called a piecewise because there's multiple pieces to the graph. Okay, there's a break in the graph. So we need to know how to write our domain and range if there's a gap in the domain or range. So let's look at the domain first. So the furthest left this graph goes is -4. And the furthest right is 3. But is there a gap in between -4 and 3 where the graph does not exist? Yes. Yeah, right in here. Okay, so I'm going to mark that as well. Okay, so the graph exists here between these two values, and it exists here between these two values, but it doesn't exist here. And that's 0, and this is -2. So we have to write our domain in pieces because there's a gap. So I'm going to say from -4 to -2, and I need to decide parentheses or brackets for that first piece. What do y'all think? From -4 to -2. Bracket for the -4, because it's a solid. Yeah, and a parenthesis at the -2, because it's an open circle. Okay, now, to indicate that there's a gap and then that picks up again, we use what's called a union. Okay, so this union symbol is just a U, like a U-turn. Okay, so that means union. And then it goes from 0 to 3. Now, both the 0 and the 3 are open circles, so those are both going to be parentheses. So I would read this as my domain is from -4, including -4, to -2, union 0 to 3. Girls, y'all stop the side conversation for me, please. We're almost done. Thank you. All right, range. Range is low to high. So the lowest my graph goes is -3, and the highest it goes is +3. Now, is there a gap in the range? Yeah. Let's take a look. These are disconnected here, but so this is at where y is 1. Okay, so if I look to the left, there's an open circle. It doesn't exist over here when y is 1, but over here it does, doesn't it? So there's actually not a break in the range. There's a physical break in the curve, in the pieces, but the range still exists where that open circle is at 1. Okay, up here at 2, where the next open circle is, it doesn't exist here, but if I look to the left, this line is over here, so it does exist. So the range does not actually have a break in it. The graph exists everywhere vertically from -3 to 3. Now at the -3, that's an open circle, and at the +3 up top, it's solid. So that one should be a bracket. So the range, the lowest it goes here is -3, and that's an open circle, so we used a parenthesis. And the highest it goes is +3, and it's solid there. So we use a bracket. And even though we see a physical gap in the pieces, the actual y values, it exists at every y value between those. So we don't need a union in our range. There's not a y value in between those where the graph does not exist. All right, the back was supposed to have these two examples. Apparently the back didn't get printed. So you're just going to do just write number 4 on the back and do a generic sketch. You don't have to draw grid lines or have all these numbered. Just draw an XY axis and this general shape. I just want to make sure you include these because on the front, none of those have arrows. They all have open or closed endpoints. But you also have to understand domain and range when there's arrows. Okay, yep, in one direction or both directions. So this one on the right, okay, so draw your XY axis and just draw a line, a linear function with a negative slope, and it's got an arrow on both ends. So the fact that it goes forever up and down, that's left and right, this is what we talked about last week. If it is a linear function, it goes on forever in both directions. So that's -infinity to positive. And we use parentheses on infinities. You can never reach infinity. You'll never equal infinity. So you use parentheses. Now, some graphs will have an arrow on one end, but not the other. So one side is going to go to infinity. So if I'm looking at the range here, this is the lowest that it goes, which is the y value of 0. And then when I look to see how high does it go, it's got an arrow. So it's going to go up to infinity. So my range will be 0 to infinity, always a parenthesis on infinity, but the 0 will be included. So even though you don't see a solid black dot, there's not an open circle, so it's assumed that it stops here at 0 and is included. Okay, so if you don't see an actual dot, that's okay. It still exists there unless you see the open circle. So for domain for this one, left to right, that is at -7, and it goes forever to the right. So -7 to infinity. And again, infinity is always a parenthesis, and we're including that -7. Okay, so I just need you to know when you see the parenthesis, arrows instead of endpoints, that means that it's going to infinity or negative infinity.
Hey, we're doing the same stuff. He was changing the code, and I was panicking, thinking, "Oh no, what if he changes the code and then he loses all that?" Can
Okay,
you look on yours real quick and tell me if he did them and what grades he got?
I'll look that up right now.
Okay.
All right, so that's the end of those. So y'all log into your Delta Math, and there's a practice there on Delta Math. I'm going to pull it up over here so you can see it. One sec, Avery. The 826 assignment. Okay, thank you. The 826 assignment has it wants you to get 6 correct from the domain and range questions. And here are buttons underneath. You can choose your bracket and parenthesis combo. There's an infinity button, and there's a union button if you need that union. Don't use the U on your keyboard. It's not a letter U. This is a union symbol. So make sure you use that button if you need a union. Okay, so you're going to get 6 of those. And then the rest of these are kind of a mixed practice to stay fresh on what we've been doing the last couple of weeks. Okay, so you've got a little bit of mixed practice after the 6 domain and range that you need to get. If anything else is showing up here under upcoming, that means you have a past assignment you haven't finished. Okay, these are still available for full credit. So you can, if you want to work on one of these first, because they're due sooner, like this one from 822, you can see it's due today. Today is the 26th. So if you need to finish that one up first, that's fine. Do that. And then this one is due the 27th. That's tomorrow. And then this one won't be due till the 28th. So you can check your due dates. If you have anything showing up under past due, that means it's incomplete and you can still do it for some late credit. Everything that you have finished will show up under complete. So just make sure you're checking both of these upcoming and past due tabs to stay on top of your work. Okay, so you can talk amongst yourselves in your groups to ask each other questions if you need to. You can ask me questions, and you can have out your notes. All right, y'all have the rest of class to practice. Yes, Avery.